3D printing has driven innovations in fields ranging from art to aerospace to medicine. However, the high-energy ultraviolet (UV) light used in most 3D printers to cure liquid resins into solid objects limits the technique's applications. Visible light curing, which would be more appropriate for some uses, such as tissue engineering and soft robotics, is slow. Now, researchers reporting in ACS Central Science have developed photopolymer resins that boost the speed of visible light curing. With the help of computer-aided design, 3D printed objects are made by the successive layering of a material into a 3D shape, with each layer solidified or cured using UV light. Being able to use visible light for curing would have advantages, including reduced cost, improved biocompatibility, greater depth of light penetration and reduced light scattering. These attributes could open up new applications for 3D printing, such as making opaque composites, multi-material structures or hydrogels containing live cells. However, because visible light is lower in energy than UV, visible light curing is currently too slow to be practical. Zachariah Page and colleagues wanted to find a way to speed up the process. The researchers developed violet, blue, green and red colored resins that contained a monomer, a photoredox catalyst (PRC), two co-initiators and an opaquing agent. When the PRC absorbed visible light from LEDs, it catalyzed the transfer of electrons between the co-initiators, which generated radicals that cause the monomer to polymerize. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.